This video will be about writing expressions. Students can easily misinterpret the language of mathematics, especially during translation from a word problem to a number sentence. This video will provide you with the vocabulary and will guide you through the process of identifying and correctly translating math terms. It will be helpful for you to have your interactive notebook open to the math word chart we filled out yesterday. We are going to start with the vocabulary necessary to truly understand writing expressions, and we're going to start with what a verbal expression is. A verbal expression is an expression written as a word phrase. Examples: 2 plus 4, or a number increased by 2. Verbal expressions can be translated to numerical or algebraic expressions by identifying numerical values, variables, and key terms that signal an operation. So, for example, identifying numerical values, all that really means is that you are turning a word sentence into a number sentence. So if we look at our example, it says 2 plus 4. So we could write that as 2 plus 4. Or the second one where it says a number increased by 2. Well, this would be, we don't know what that number is, so we would say a number, we can call that x. Increased by is a plus, and then 2. Okay? A numerical expression is a mathematical phrase that contains only numbers and operation systems. Very important. I would highlight that or underline it. Only numbers and operation symbols. So as we look here, some examples, we have 60 plus 25. Notice number, operation symbol. 42 divided by 7. Numbers, operation symbol. 4 squared minus 3. Numbers, operation symbols. Numerical expression. What word do you kind of see in there is number. So numerical expressions only contain numbers and operation system and symbols. An algebraic expression is a combination of variables, numbers, and at least one operation. So an algebraic expression is a combination of variables, numbers, and at least one operation. When we talk about variables, most time we're going to be talking about x, y, or z, but for that matter, it could be any letter of the alphabet. Okay? So if we look at the examples, we see 5 plus n. So 5 plus n, we have a number, an operation system or symbol, and a variable. Okay? Looking at the second one, we have 7a. Now 7a, you have to understand, really means 7 times a, but we simply write it as 7a. So here is my number, there is my variable, and my operation system or symbol is going to sit in the middle as multiplication. But again, we simply write it as 7a. Our last one, again, we have a variable, a number. The subtraction is our operation symbol, so we can understand that this is going to be an algebraic expression. So let's go back and circle the variable in each expression. We have n in the first one, a in the second one, and k is our variable in the third one. So let's think about this. Explain the difference between a numerical expression and an algebraic expression. Please write what you believe is the difference between a numerical expression and algebraic expression. A numerical expression has only numbers and operation symbols. Algebraic expressions, the difference is they have variables, numbers, and operation symbols. Okay, on this slide, we're going to identify each as a numerical expression or as an algebraic expression. All right, and I would like you to try and explain your answer to yourself of why each answer is going to go in a particular place. So what I'm going to do is, obviously we can't drag the expressions through this video. So I'm just going to write and then cross off. So if I look at the first one, it's 9. It's 9 minus D. Well, I see a number, an operation symbol, and a variable. And I know that as soon as I see a variable, that tells me that it's going to go over under the algebraic expression. So 9 minus D. So I'm going to go through and I'm going to look through every expression and see if I can find one that has a variable in it. The next one I see is 5 times the difference of x minus 4, because there you go, there's my variable, so I know that that's going to be an algebraic expression. So we're going to write that over here. And then the last algebraic expression I see is x minus 12, because again we have that x there. Okay. The rest I'm going to write under numerical expressions, and you can see, because the first one, it says 6 times 24 divided by the quantity 8 minus 5. They are all numbers and operation symbols. And then as we keep looking, we have 17 plus 5 to the cubed. Again, all numbers. And then finally 3 plus 6. Again, all numbers. What I'd like you to do on this page is to pause the video and fill in the blocks with words that we discussed yesterday that represent addition, subtraction, multiplication, and division. I would like to see at least 4 words per block. Very important things to remember as we move forward. 1. Letters in algebra are called variables because their values can vary. Variables. And remember, most often they're going to be lowercase letters represented by X, Y, and Z, but it can be any letter in the alphabet. When multiplying a number and a variable, the number is written first. For example, x times 5 is written as 5x, not x5. So it would be represented as 5x. And you need to be very, very, very careful that you don't use subtraction in the wrong order, because if you do, the answer is going to be incorrect. So for example, where it says the difference of 5 and t and 5 decreased by t are translated as 5 minus t. Whereas you see 5 less than t and 5 subtracted from t are translated as t minus 5. Now, I know in one of my classes we talked about this, and we see these words right here, less than, and we see from. And when we see those words, we know that those are reverse words. So when we see them in a sentence, we know that we need to reverse the order in which I would write my number sentence. So if you saw less than and wrote 5 minus t, you would know that you would have to switch the 5 and the t. Very important to remember. So I would star this, highlight it somewhere on that paper, and remember that those are important. Now the phrases that are grouped together all represent the same the same numerical expression. Okay, so 9 more than a number, the sum of 9 and a number plus 9, a number increased by 9, the total of x and 9, all represent a numerical expression that looks like x plus 9. Remember, if we don't know what that number is, we're going to call it x. Let's look at the next one. 4 subtracted from a number minus 4. 4 less than, and I'm going to underline this real quick because we need to recognize those two words. A number decreased by 4. The difference of h and 4. So they're telling us that our number that we don't know the value of is going to be h, and we're going to subtract 4 from it. Let's look at the next one. 6 multiplied by g. 6 times a number. The product of g and 6. Well, we know the product is the answer to a multiplication problem. So our numerical expression is going to look like 6g. Remember, the number comes first, then the variable. The last one. A number divided by 5. The quotient of t and 5. Divide a number by 5. So our number that we don't know the value of, we're going to call t, and we're going to divide that by 5. You could have also written this as t over 5, like a fraction, because remember, a fraction is a division problem. For the next 2 slides, what I'm going to do is I'm going to complete the first one for you, and you are going to complete the rest. So it says write an algebraic expression for each word phrase. So my first word phrase says 5 plus a number d. So I'm going to write 5 plus d. Now I expect you to write the rest, and we will go over it on Friday. On this slide, they have given you a sentence. It's not necessarily a word problem, but they're expecting you to be able to translate what would be a tiny word problem into a numerical expression. So the first one says 7 less monkeys than Michael. And if you recognize, here we have less than. So here's Michael. I'm going to represent him by M. We have 7 less monkeys than him. So it would be the numerical expression would look like M minus 7. Complete the other 3 on your own, and we'll go over them on Friday. On this slide, we're now going to go backwards. You are going to use the words that we had sorted out on Wednesday, and you are going to create a verbal expression. So now we're going from a numerical expression to verbal. We're going from numbers to words. So again, I will do the first one, and please try to be a little more creative than simply writing Q plus 5. I would like to see you write a more thoughtful sentence. If you can, try your best. So for the first one, zoom in just a little bit more. I'm going to write the sum of Q and 5. So again, please try to be a little more creative. Know that y/5 also means y divided by 5, okay? And 12x really could be represented by 12 times x. I would like to see nice completed expressions, and we'll go over this on Friday as well. after you finish the video and the problems that were left over from the video, you may begin the homework. You may either complete a paper copy or do the homework on a backpack and turn in through there.